Hello dear students, welcome to a new session of physics today. In today's session we are going to learn graphical representation of motion. आज के इस वीडियो में हम सीखेंगे कैसे हम किसी ऑब्जेक्ट के मोशन को ग्राफिकली रिप्रेजेंट कर सकते हैं. So before I get started with the video, I want you all to grab a graph copy and be ready with your stationery, because you need to practice the graph. Just by watching the graph you may have little understanding, but you need to practice the graph. So it's a humble request, be ready with your graph and pause the video wherever required, plot the graph, solve the question and then check your answer yourself. So let's get started. So in this chapter there are certain things that we are going to learn, and the first is the types of graph. Well, in class 7 you must have been introduced to the types of graph like the distance type graph. But in class 9 we are going to learn even more types of graph. So let us list all the types of graph that we are going to study. So the first one is distance time graph, the second is displacement time graph, and the third is position time graph. In fact, displacement time graph and position time graph both are in fact same. Coming to the next one is speed time graph, next we have velocity time graph, and last but not the least acceleration time graph. So if you look at all these 6 types of graph over here, we have time common in all, right? So we are plotting all these against time. So we are going to take time in the x-axis, and we will take these distance or displacement, position, speed, velocity or acceleration in the y-axis. So if I write over here distance, then this graph will be called as distance time graph. If I write over here in the y-axis displacement, then this graph will be called as displacement time graph. Okay, now one thing to see over here is I have highlighted the distance time graph and speed time graph in red, whereas all the other graphs are in black. So what could be the reason behind this? Well, you know, distance and speed, these both are scalar quantities. They are scalar quantities, which means that they have only magnitude. We do not require direction to express them, which also means that the value of distance can never be negative, it is always positive. Similarly, the value of speed is always positive. It means that in y-axis we only need the positive, not the negative part, and that is why distance time graph and speed time graph can easily be represented in the first quadrant. We do not require second, third or fourth quadrant to represent distance time graph and speed time graph. Whereas if we see the other 4 like displacement time graph, position time graph, velocity and acceleration, we require both first quadrant as well as fourth quadrant. Why? Just because, as we know, displacement is a vector quantity. It's a vector quantity, which means that we need both the magnitude and direction in order to represent displacement, which also means that the displacement can be both positive and negative. So when the displacement will be positive, we will need the positive y-axis. When the displacement is negative, we will require the negative y-axis, and that is why the graph will be lying in both the quadrants, first and the fourth. Same is true for velocity time graph and acceleration time graph. So I hope you have got a brief idea about the types of graph and which quadrant the graph is going to lie. Now coming to the next topic in this graph, we have to study basically 2 important concepts, or you can say tools, which are going to help us analyze the graph. The reason why we are plotting the graph or studying the graph is to analyze the motion of the object, and these two tools are going to help us analyze every time. The first is the slope of a graph and the second is area under the graph. So what do we mean by a slope of a graph? As you can see here in the first graph, I am trying to show what is the slope of a graph basically means. So the slope of the graph basically means how slant is the graph with respect to the time or horizontal axis, whereas the area under the graph is basically the portion of the graph covered below the line AB and above the time axis. So we'll learn both the concepts in quite a detail and then start bring some numericals. So let us see a summary on the two concepts, slope and area. Let's say we are given distance time graph or displacement time graph, speed time graph or velocity time graph, and we are calculating slope for these graphs. So what are we going to get? So the answer is all on your screen. As you can see here, if we are finding the slope of a distance time graph, we get speed, and if we find the slope of a displacement time graph, we are going to get velocity. For a speed time graph, if we calculate slope, we will get acceleration, and for a velocity time graph, if we calculate slope, we get again acceleration over here. So how do we remember this, like which graph is going to give which quantity? Well, it's very easy to remember. If you can see over here, we know from our basic concepts like distance divided by time is the speed, right? And if you remember, we are plotting distance in the y-axis and we are plotting time in the x-axis. So if we divide the y-axis quantity with the x-axis quantity, if we are dividing, we are getting speed over here. So this is distance divided by time is speed. Similarly, we know displacement divided by time is going to give us velocity. Similarly, speed divided by time is acceleration, and velocity divided by time is also acceleration. So if we want to find speed in a distance time graph, so we just need to find the slope. Similarly, if you want to find velocity in a displacement time graph, you just need to find the slope. So I hope this is clear to all. It is very intuitive and easy to remember. Now let us understand what we will get when we are calculating the area under the graph. So basically, when I say area under the graph, we are basically multiplying the y-axis quantities with the x-axis quantities. So if this is your, let's say, speed and this quantity is your time, so if you multiply speed into time, basically we get distance, and this is what is given over here. So when we multiply speed with time, we get distance. If we multiply velocity with time, we get displacement. So this is very intuitive what we are getting when we are calculating area under the graph. But one thing to just see over here, if I multiply here distance with time, it means if I am finding the area of a distance time graph, I am not getting any relevant quantity, because distance into time is of no use to us. We don't know such quantities. So I have crossed here. And similarly, in displacement time graph, if you are calculating area, it will give us a quantity that is of no use to us. So I hope this short summary is clear. You can take a screenshot and even write this in your notes. It's very important to understand what does the slope or the area of a graph is going to give and what does it basically mean. Now it's time for us to get the topic of slope and area in detail. So let us understand exactly what is slope of a graph. So here in this graph, There are three graphs over here and there are three lines AB as shown over here, and you can just see over here the three graphs have got different slant. The first graph has got more slant than the second one, and the second one is even more slant than the third one. And in mathematics, when you study in higher classes, you'll find that the slope is represented by a letter small m. So for the third graph, slope is given over here as 5. For the second graph, slope is 10, which is more than the first one. And for the third graph, the slope is 20, which is the highest over here. So you can see very easily, if the slant of the graph is more, the value of the slope is more. And here it is 10, which is less than 20, and this is 5. Okay. Now question comes, how can we calculate these numbers? How can we calculate this slope as 20, 10 and 5? So let us take the first graph. Let us take one point, let's say point B. So this point B, the y coordinate of the point B is, as you can see, is 40 in all the graphs over here. The y coordinate is 40, and if I see the x coordinate over here, for the first graph it is 2. So if I want to find the slope just by dividing the y-axis quantity with the x-axis quantity, so if I say here slope is equals to y by x, if I take the value as 40 by 2, I am getting this as 20, which is also given over here. Similarly, if I take for the second graph over here, the slope m will be equals to the value in the y-axis, that is 40, divided by 4, and that is going to give us 10, which is the answer like this. And for the third graph, again if I take the value of y-axis as 40 and x-axis as 8, I am getting the slope as 5. So this is an easy way to find the slope, but I'll tell you this method is going to be wrong in other graphs. So this is not the right way of finding slope. I will give that answer in the next slide. But for now, let us understand, what if I find the slope using some other point? Let's say I take this point and I want to find the slope using this point. So if I take the value of y and x according to this one, I will get again over here m is equals to y, the value in the y coordinate is 20 and in the x it is basically 1. So this is 20 by 1, that is also going to give us 20. So on this line, no matter where I find the slope using this point or this point, I am getting the value as 20, which is same, which means that the slope of this graph is fixed. Similarly, for this second graph, if I take, let's say, this point and I find the slope using this point, then we can see the corresponding points over here in y-axis is 20 and x is 2. So the slope will be equals to 20 divided by 2, and that is 10, which is same as what we calculated earlier. So for this graph, no matter where I choose the point, if I know the coordinates, I am going to get the same value, and that is 10. And for the third graph, let us take this point over here and calculate. You can see the value is going to be 20 by 4. So you get the same answer. 20 by 4, that is 5. So one thing to remember here, for a straight line, no matter where I take the point, the slope is going to be fixed. But I also told you that this method of choosing one point and seeing their y coordinate and x coordinate and dividing them to get the slope is actually a wrong method to calculate the slope. This method is not going to be useful in other graphs. So let us see why I am saying this. So let us take a graph like this, and you can see this graph is not starting from 0. In the first graph, we saw that all the graphs start from the origin. It is starting from 0. But this particular graph is not starting from 0. So if I apply the same concept that we have done earlier, let us see what is the mistake over here. So let us choose one point. Let us say I use this point, I call this point A, and I want to find the slope using this point. So I'll write here m is equals to, the value in y is 60 and the value in x is 4. So this is 60 by 4 and that is equals to 15. Now if I choose, let's say, a point over here, the corresponding values in y is 80 and 8. So if I find the slope, m will be equals to 80 by 8 and that is equals to 10. You can see the slope is varying. The slope is coming as 15 and now it is coming as 10, but for a straight line the slope cannot change. The slope has to be constant, but here I am getting different answer because the method of finding the slope is wrong. Let us take one more point for reference. Let us take this point as C, and if I find the slope using one point C and see its corresponding value in y and x, this is 12 in x and 100 in y, so the slope will be 100 by 12 and that is 8 point something. So you can see the values keeps varying, 15, 10 and 8, but the answers are all wrong. So this method of finding slope where the graph is starting from 0, you can choose this shortcut y by x, but where the graph is not starting from 0, we need to find it in a different way. So let us learn the correct method to find the slope of a line. So we have a general line like this in the first quadrant. So let us take any 2 points, not a single point, but this time we will take any 2 points over here. So the first point I am calling it as A, and the corresponding value in x-axis I am calling it as x1, and the value in y I am calling as y1. So let us say this is y-axis and this is x-axis. And let us take one more point on the same graph. So I take this point as B. So the value in the y-axis, let this be called as y2, and in the x, let this be called as x2. So here we have got 2 points A and B, which is lying on the graph. So what we are supposed to do, we need to imagine a right angle triangle including these 2 points. So here I consider AB as the hypotenuse and I imagine a right angle triangle like this, A, B, let me call this point as O. So this forms a right angle triangle. So in order to find the slope of a line, now we need to focus on this triangle that we have taken over here, and what we basically need to do is we need to find the height of the triangle and the base of the triangle, because slope of the line basically here it is going to mean slope m will be equals to the height of the triangle divided by the base of the triangle, okay, or we can call this as BO by OA. This is the definition of what slope is, okay, the ratio of height to the base. Now in order to find the height, you all know in coordinate geometry, like this distance h will be y2 minus y1. So h is equals to y2 minus y1, and b is going to be, the final value here is x2 and the initial is x1. So the difference is going to be x2 minus x1. So we can write over here, this is BO length will be y2 minus y1 and the length of OA will be x2 minus x1. This is the general formula for finding slope. It is applicable not only in physics, but this is what basically is the formula coming from the mathematics, okay. So slope is basically change in y by change in x. This is the definition of slope, change in y-axis divided by change in x-axis. Sometimes we also use terms like, if we call this as run and we call the height as rise. So basically slope is equals to rise by run. So I hope you got the definition of what is slope and how we can calculate. But it depends on the graph. If I call this as distance time graph, then I will be calling slope as d2 minus d1 divided by t2 minus t1. If it is a velocity time graph, then I'll be calling slope as v2 minus v1 divided by t2 minus t1. So the thing is that the variables will keep changing if I change the name of the graph, but this is how we calculate the slope of a graph. Now here in this graph, as I have taken a triangle on my own, but you can choose any triangle or any 2 points on the graph. It is not necessary that you have to choose only these 2 fixed points. You can choose any point whose coordinates are known to you and is clear to you. So you can choose any point above, or you can also choose any point down, but thing is that the points, the value should be clear to you. And you can also take the small triangle or bigger triangle, both are going to be fine. The answer will be actually same no matter whether you take the small triangle or you take the big triangle. We will prove this in the questions. So this is all about the slope, how we find the slope. Now it's time for us to apply the concepts that we have learned in the velocity time graph. And I am going to give all examples of velocity time graph in this video. In the next video, I'll try to take up some other types of graph, but this video is going to be only on velocity time graph. So let us take this question. The question is, find the slope of the velocity time graph. Well, we have to find slope of this graph AB. This is velocity in the y-axis and time in the x-axis. So here let's say I take one point as B, and let us choose any one point on this graph. Let's say I take this point somewhere here, because its coordinate is clear to us. It is going to be 20 and 2 for, let me call this point P, and for point B it is going to be 40 and 4. So if I consider this right angle triangle over here, then, and let me call this point as O. So the length or the height of this triangle BO is going to be 40 minus 20. So let us write the formula first of all. Slope M is equals to, let me call this as V2 as the final velocity and P is the initial velocity. Why? Because we are going from P to Q. So this will be called initial. You can also call it as U. In fact, this can be called as U and this can be called as V. So we can write the formula over here as V2 minus V1 divided by T2 minus T1. So for initial point P, I will take the time as T1, and for the final point B, I will take the time as T2. So this is V2 minus V1 divided by T2 minus T1. Now let's put the value. So V2 is 40 meter per second and V1 is 20 meter per second. I'll write the units also for clarification, and let's write the corresponding time over here. T2 is, from the graph, it is 4 seconds and T1 is 2 seconds over here. So I'll write over here second. Let's solve this further. 40 minus 20 is of course 20 and 4 minus 2 is 2, and meter per second, this becomes meter per second square. Children, you all know this is the unit of acceleration. So remember, I told you when we find the slope of a velocity time graph, we are going to obtain acceleration. So we get here acceleration A is equals to 10 meter per second square. So whether the question says find slope of a velocity time graph, basically they are asking what is the acceleration of the velocity time graph. And here the answer that we have got is 10. This is basically plus 10 meter per second square. Why I am putting plus 10 over here? You can see as the time increases, the velocity is increasing. It is 10 over here, and then 20, then 30 and 40. So acceleration of this graph is plus 10, which means that in every second the velocity is increasing by 10 meter per second. So this is the answer of the first question. Well, if you want to choose some other point, and let's take you want to use this triangle A, P, and let me call this point Q. You can try this. You will get the same answer as 10 meter per second square. And if you want to take some other triangle, the biggest triangle possible over here, let's say you want to choose this triangle including points A, B, and whatever you call this, let me call this as point M. Then A, B, M, if you take this triangle and take the corresponding values of velocity and time, you get the same answer. Let me solve this quickly for you. For this bigger triangle, if I have to calculate the slope, I'll call M is equals to V2 minus V1. So for point B, it will be V2, let me write the formula first, V2 minus V1 by T2 minus T1. So for point B, the velocity is 40. For point P, the velocity is 20. For point A, the velocity is 0. For point B, the time is 4 seconds. And for point A, time is 0. This is 4 minus 0. So basically this is 40 by 4, and that is 10 meter per second square. So I have told you, you can take any triangle or any 2 points and you can get the same answer for a straight line. So this is the answer of the question number 1. Now let's get to the second part of the question. Question number 2 is find the slope of a velocity time graph, and this is where you can see the graph is not starting from origin. It starts from 20, which means that the object has an initial velocity of 20. So we need to find the slope, or hence the acceleration of the velocity time graph. So let's take 2 points on this graph, and I'll again choose this point. Let me call this as P. This is B, and let this be O. So if I have to find the slope of this part of the graph, I will call this as V2, corresponding to, because this is my initial point, this is my final point. This must be clear to everyone, because graph is going from 2 to 4. So this is your initial point and B is your final point. So when I write here M is equals to V2 minus V1 by T2 minus T1. So V2 and T2 corresponds to the final position, and V1 and T1 corresponds to initial position. So from here, let's put the value. For point B, the final position V2 will be 40. For point P, V1 is 30. Similarly, for point B, this is T2 and this is T1. So T2 is 4 seconds and T1 is 2 seconds. Let me write the units over here. This is 40 minus 30, that is 10 divided by 2, and this is 5 meter per second square. If you would have taken this point directly, 40, and divided by 4, that is this value, 40 divided by 4, you will get the answer as 10, and that is actually wrong. So 40 by 4 will not give you the right answer. This is wrong. Got it? Again, as I have told you, you can choose any 2 points. You can choose A and P to form a triangle like this and get the answer as 5 meter per second square. Or if you want to choose A and B as a point for the triangle, you can solve, you get the same answer. So I'm not going to do that in the solution over here. Now let's see the next question, number 3. In the question number 3, we have a graph from point A to B which is parallel to time axis, which means as the time increases, velocity is not increasing, velocity is constant. Velocity is constant. So what is the acceleration for such graphs? Well, if velocity is constant means velocity is not changing, velocity is not changing, this means acceleration is 0. The object has got no acceleration. But how can we calculate using the formula? So let A be your initial point and B be your final point. Now this time I am going to write the coordinates of A and B. So we first write the coordinate of time and then velocity. So time for point B will be 6 seconds and velocity for point B is 40 meter per second. Similarly for point A, if I write the coordinates, this will be 0 seconds and 40 meter per second. And now let's apply the formula over here. Slope is equals to V2 minus V1 divided by T2 minus T1. So this is our V2, this is our V1, this is our T2, this is our T1. So let us subtract and get the answer over here. This is 40 minus 40 by 6 minus 0. So you can see the numerator gets actually cancelled out. So this is 0 by 6 and hence acceleration is 0. The object has got 0 acceleration. So this is a simple answer for a velocity time graph. Sometimes children get confused when they see a graph which is horizontal to time axis. They think that the object is at rest. Well, that is true for distance time graph but not for a velocity time graph. Okay, you need to have little understanding on this. Here the velocity is not 0, velocity is 40, which means that the object is still moving with 40 as the time proceeds. So object is not at rest, object is moving uniformly. Now let's see a question number 4, which is a graph, an interesting graph. This is a graph for an object like a train which starts from one station, moves for a certain time and again stops at the other station. So for any vehicle in real life, when it starts from 0, they accelerate, then moves with a constant velocity, then the driver applies the brake and the object comes to rest. So it's a very interesting graph, you'll find very often in the question. So let us now answer the question which is given over here. The first part of the question says find the acceleration of the velocity time graph between 0 to 2 seconds. So we have been asked acceleration, which means that we have to find slope, right? So between 0 to 2 seconds, right? 0 to 2 seconds means in this portion of the graph, that is from A to B. 0 to 2 seconds means from A to B we have to calculate the slope. So how do we do it? Here I'll ask you to pause the video until you get the solution, try it yourself, and once you have got the answer, then you can come and verify it. So I hope you have done and got the answer. So let us check the answer right now. So shall I take a point A and B as the biggest triangle, and then we can choose in fact any triangle on the graph which I am trying to show over here, but let me take the bigger triangle over here. So this is a final point. So the position of point B, as you can see here, in time it is 2 seconds and velocity is 40 meter per second. For point A, time is 0, velocity is again 0. So we can calculate the slope over here. That will be, for point A, I am writing here slope is equals to acceleration, and that is equals to V2 minus V1 by T2 minus T1 You can also write as v minus u divided by t2 minus t1. So let us put the value. This is 40 minus 0 meter per second divided by 2 seconds minus 0 seconds, and that is equals to 40 by 2, and that is 20 meter per second square. So you can again see the answer is positive, and I intentionally write it as positive 20 meter per second square to emphasize on the fact that the acceleration is positive, which means that the velocity of the object is increasing. Sometimes you think, okay, why there is a need to write plus sign? Well, it is understood, but I always emphasize because children keep getting confused. When they don't write positive, they don't get the feel of it. So here it is not just 20, it is plus 20, which means that this is positive acceleration. This is positive acceleration. Now the second part of the question is to find the acceleration of the graph between 2 to 8 seconds. That is 2 to 8 seconds will include the point B to C. So we need to find the slope of this portion of the graph, and we have done the calculation earlier, and we have seen that for a graph which is horizontal in a velocity time graph, acceleration is 0. The object's velocity is not increasing. So this is positive acceleration. This is called zero acceleration. And we have the third question, which is over here, to calculate acceleration between 8 seconds to 12 seconds. So how do I calculate the slope of the graph between C and D? So let me see if I have, yes, so I'll solve over here. So let us take in this point, and let me call this as E. So we have taken 2 points on the graph. The mistake that children do is that they don't differentiate like which is the initial point and which is the final point. So here you can see the graph is going from 8 seconds to 12 seconds, which means that this is C is your initial point and E is the final point. Okay, so if we write the coordinates properly over here, let us see the coordinates. For point C, the x coordinate is x 8 seconds and the y coordinate is, in the velocity we have 40 meter per second. Similarly for point E, this is going to be 10 seconds and in the velocity we have got 20 meter per second. So this is your V2, this is your V1, this is your T2 and this is your T1. You can even represent over here, this is your V1 and this is your V2. You can see that this is changed now, and this is your T1 and this is your T2. So let us write the formula and solve number C. We have to solve acceleration, so I'll write over here acceleration is equal to slope, and that is equals to V2 minus V1 divided by T2 minus T1. So I'll now put the values 20 minus 40 meter per second divided by, this is 10 minus 8 seconds. So you can see the answer is minus 20 by 2 and the answer is coming negative 10 meter per second square, which means that the object has a negative acceleration. So the A is coming as minus 10 meter per second square, which means that the velocity of the object is decreasing. So decreasing velocity means that the object has got negative acceleration, which is also called as retardation. Basically retardation is written as 10 meter per second square, which is the negative of the acceleration. So you can call this as deceleration or retardation, which is minus of acceleration. Anyways, I'll not get into this right now. Let us focus on graph. So we have got the first part of the graph as a is equals to 20 meter per second plus 20 meter per second square. This is positive acceleration. This is zero acceleration, and this is negative acceleration. So we have calculated the slope and acceleration for all the graphs given over here. So that is all for this session. The part 2 of this video will be on the area under the graph.